Hello everybody, we're Lab Group C, and today we're going to be discussing the video portion of our lab that we've been assigned. My name is Mahler.
John Forrest.
Abhinav, Mishra.
Seth, Suydam.
And I'm Metcalf. And I'm going to talk to you first. So, 2C, the question is, what are the borehole environmental conditions that can affect gamma ray reading? So the first one is the hole size. So if the hole size increases, the amount of radioactive material being measured and collected is going to decrease because the detector can't pick up all of it, even though the actual amount of radioactive material in the hole is the same. And then another one is KCl mud. So with KCl mud, the gamma ray is going to increase because of the potassium reading.
I'm going to discuss part of question 4D, which asks you to describe the effect that the volume of shell will have on gamma ray and also on the caliper diameter reading. So as your volume of shell increases, you're going to have more gamma ray, and so your gamma ray reading is going to increase based on the thorium, uranium, and potassium that's in the reservoir. And then also in a shell, your caliper diameter is going to increase because shells are very unstable. They break apart. If you hold it in your hand, you can literally break it. So you can imagine as you drill down through a shell, it's likely that it would cave off, therefore having a bigger diameter than the bit. So therefore your caliper reading would be bigger than the size of the bit.
And I will be discussing the effects on resistivity with volume of shale. As shale has a large clay constituent as part of it, it lowers the resistivity because clay acts as a conductor, and due to the low permeability in a shale, you will see the 10, 30, and 90-inch resistivity investigation tracks stacked on top of each other.
All right, we're going to talk about question 5. Come on over here. Let me show you this. We want to indicate where the net zones are, and we do that using our volume shale and our resistivity logs. The deep resistivity is green, and it gets higher in this area, indicating hydrocarbons. And we look at our volume shale. Wherever it is less than 30%, we're going to count it as clean. And that's how we determine where our clean zones are to use in our net to gross calculation.
Thank you, Seth.
I'm here to calculate net gross from a gamma ray log correlation. And basically the first step is calculating the IGR, linear approach to a gamma ray log correlation. And basically what you're doing is getting the value from the gamma ray log itself, subtracting it from the calculated gamma ray clean value, which we got from the histogram, then dividing that over the gamma ray shale value, which we also got from the histogram, and then subtracting that by the gamma ray clean value once again. After that, you go into the Clavier correction, which makes the V shale value much more accurate than what you would get from IGR. So you plug IGR into this equation and you plot Clavier corrections with depth. So you have your clean sand cutoff 30%, which is given by the company, or in our case the professor gave it to us. So everything to the right is shale, everything to the left for us is clean sandstone. So how do we go about getting gross, net, and net to gross values from this? Basically, gross is the depth of your entire formation. So that would be 7,000 minus 4,000, which is 3,000 foot. Then you go down to net, and that's your net pay zone, and that is pretty much all your sandstone that you're looking for. Sandstone would be this area. So we can say that this is 1,000 foot. Then you go to net to gross. This is simply a fraction of net over gross, and that is 1/3.